So that was quite a long segment on memory management, but we've not quite finished. But people probably needed a break. So we're coming back to these things that we may be beginning to guess what they are by their name now, auto-release pools, and we've talked about this thing called auto-release, so I'm assuming the two things are associated in some way, but now you're going to tell us.
Yes, yes. So, you know, you might have looked at auto-release and you might have thought, well, that's interesting. How does this promise, you know, we talked about how an auto-release is essentially a promise from the runtime that your object will eventually be released, right? And so you might be thinking, well, how does the runtime make this promise? How does the environment do this work? And at the same time, you know, we've shown a lot of examples from the templates where we have this this line in them, this NS auto release pool that seems to be in all of our example code. What is this thing, and how does it relate to the auto release method? And the answer is, so essentially when you call auto release on an object, what actually happens is a reference to that object is added to the auto release pool. All applications have an auto release pool, at least all of the ones that are created through, you know, the standard Xcode templates. There's always an auto release pool that's included, and in particular, for example, if you're creating any application like a Mac OS X GUI application or an iOS application or something along those lines.
I think it's safe to say a Cocoa or Cocoa Touch application. Yeah. The auto release pools are in there. They're
in there. They're running in the main run loop of your application automatically. But if you're dealing with command line applications that don't have a run loop, like the ones that we've been using for examples here, it has to be manually created, and that's why you'll see in the templates, you'll always see these lines like we've got here, where it's showing where it's actually creating the auto release pool and so forth.
So when we write some bigger applications, our iPhone, iPad, Cocoa applications, we're probably not going to see this piece of code in there.
Correct. You're not going to see it.
But it's going on in the framework.
It's there. You're just not going to see it. So again, when you call auto release, your object is added to an auto release pool, and then at the bottom of every loop through your application's run loop, you know, when you have a Cocoa application, there's actually a run loop that's running in the background that's handling your events and things like that. When the run loop reaches the end, when it's got nothing else to do, it drains the auto release pool. And the act of draining the auto release pool actually is the thing that actually reduces the retain count on all of the objects in the auto release pool. And if any of those objects have a retain count of 0 after they've been decremented, then those objects are deallocated. So that's basically the way that auto release pools work. Make sense?
That makes perfect sense. So in our case here, with a command line application, actually it's in the main function, which is where our application starts and ends. So really, the auto release pool gets created at the beginning and gets drained at the very end for this application.
Exactly. It's created here, and then, for example, you know, here's an object that has been auto released, right? Because it was gotten from something that didn't have one of those copy or alloc method names in it, and then when the pool is drained, that's when the release is sent to that array object. And so if it has a retain count then of 0, then the object will be released.
Okay, so here we can see very much when it's happening in a sort of GUI application or an iPhone application, it's more just understanding it's going to happen at certain times.
Yes, and you know, and really the key when you're working with a Cocoa application or a Cocoa Touch application is simply to assume that your run loop is going to run anytime you give up control of the thread of execution in your application. So anytime you exit a method, or there are certain methods that you can call on NSObject that will run the current run loop for a loop. Anytime you do anything like that, you have to assume that the auto release pool is going to be drained, and so you better have all of your ducks in a row at that point.
So which is why, on the whole, it's safe to say that within the scope of where you've received the auto release object is going to be safe because you're still within your method.
Exactly.
Unless within that method you are handing control back to, I don't know why I'm doing this, handing control back to the run loop.
Exactly.
In which case you're then unsafe.
Exactly. That's why you need, that's why it's safe to use those objects within the scope of the current stack, but as soon as you leave the current stack, you had better have retained anything you want to keep around.
But on the whole, for most things we do, that's fine. So, for example, if I set up a single form and it's got a button on it, and that button's connected to some code, you know, that button click, the running of that code, the coming back to the GUI, that's going to be in a single thing. Those are going to be safe on the whole, unless we do something like we've just said.
Right. Now, auto-release pools are kind of cool. You know, they give us this capability, right? You know, they give the ability to do all this neat stuff that's, you know, really kind of integrated with the whole memory management system. But there's also another cool thing about auto-release pools, or another interesting application of auto-release pools, and that is, let's take a look at an example piece of code here. This code here, this method called inflate memory usage. I imagine you can probably tell what it does, right? Well, let's take a look at it and break it down. Essentially, we're looping 100,000 times in a tight for loop, right? You remember when we were working with for loops, and on each one of those, we are getting a big blob of data, okay, from somewhere else.
Nice descriptive method, right? Very good.
And again, when we get this data, right, does this method contain create? Does it contain alloc? Does it contain copy? It does not, right?
We don't care. It's not It's not one of those in the rules. Yeah, so it's going to be an auto-released object.
So it's going to be an auto-released object, right? And then we basically do stuff with that data. So we pass it off to something else and let it do its thing. Now, there's a little bit of a problem here in that because each one of these guys is auto-released, right? When is the data that we've gotten back? Let's assume that the get big blob of data is actually, maybe it's going off and reading a file or something, and reading this big chunk of data off of disk and then handing it off to do stuff. And then do stuff doesn't need it anymore after it's done with it. When is data being deallocated?
Well, definitely not before it drops out the end of inflate memory usage as a method altogether.
Exactly. Because at no point here are we actually running the run loop of our application. Data is not being released inside of this method. So we could be doing this 100,000 times, and each one of these could be 5 gigs or something. Okay, maybe not 5 gigs.
I think you're making a very big point here.
Let's say 100 megs, all right? 100 megs. And then the next thing we know, we're actually, well, maybe we're actually taking up 5
your
gigs.
Your MacBook Air or your iPhone has melted.
Yeah, it has melted. That's absolutely correct. And the problem is because at no point in this tight loop have we given up control to the run loop so that the auto-release pool can be drained, right? Mm-hmm. That's the problem with this code. At no point is the auto-release pool being drained, and so data is not being sent a release method, a message. So there's a couple of ways that we can fix this. The first one is we can actually create our own auto-release pools at any time. And the way that auto-release pools work is it's almost like a stack. If you create one inside of another auto-release pool and then you create a bunch of objects inside that auto-release pool, then they'll be part of that outer auto-release pool or inner auto-release pool.
Right, okay, so basically you can keep creating them as often as you like, and when you auto-release something, it will always go into the most recent auto-release pool.
Correct.
If it exists.
Correct. And you can release that auto-release pool anytime you want. And that means that when you release that auto-release pool, all of the objects that have been added to it also get released.
So when you release the pool, it effectively drains as part of its release, and then it will drop back to whatever the next auto-release pool is, I guess.
Exactly. So that's exactly what this code is doing here. Again, we're still doing the same 100,000 iterations over this data set, but inside of this for loop, I've created an NS auto release pool, right? And then when I go and I get this new data is going to be auto released, so it's going to be added to this auto release pool here. Then I go and I do stuff with the data, and then I call pool release, and the auto released objects are then deallocated. Make sense?
It makes loads of sense. So now data is getting released every iteration as opposed to right at the end of the loop.
Exactly. Now, so this is one way to do this. You could do it where you've got this, where you're actually creating the auto release pool on each iteration. That might be a little bit performance intensive because you're creating this auto release pool over and over and over again every time you iterate over this thing. That could be a little expensive. So another way to do this also would be perhaps to create your auto release pool outside of the for loop first, right? And then you're still iterating over this loop. You're still adding the data to that auto release pool, and you're still doing stuff with it, but instead of actually releasing it because you want to keep reusing this auto release pool over and over again, you just do a drain. It doesn't actually release the auto release pool. It actually executes that call to release all of the objects in it. And actually, there's actually an error in here because we would still have to release the auto release pool.
I guess you don't ever want to auto release an auto release pool.
You could.
You could.
There's no reason that you couldn't, because assuming that you're putting that you have an auto release pool out there running, there's no reason you couldn't. But I don't think there's any reason to do that. I don't think you would typically.
And I guess again in there we could then move down to, because even draining the pool every iteration might be expensive, but you could say every 100 iterations I want to drain the pool, every 1,000.
That's exactly right. Yes, you could do it every 100 iterations or whatever, very easily. Just put in here, something like if n modulo 100 equals 0. Right, something like that would drain it every 100 iterations.
So really, we've got actually incredibly friendly memory management. I mean, if you've ever tried to just memory manage in C or Pascal or C++, where it really is a case of having no idea who's using the object and you're taking a wild guess at when, I think is a fair way of describing it, of when you can get rid of that memory. The whole retain release mechanism is very simple in comparison.
It really is.
It's very easy to use, and yet with things like auto release pools and this, we've got so much flexibility. It's not like sometimes memory you feel it's been taken out of your hand and you've no longer got control and it's going to do silly things. We can bring this stuff under our own control. Right. It's really quite cool.
Right, it is. One of the things that a lot of developers who come from C or C++ find is that when you're working with C and C++, you work with like these third-party libraries and things, and not only 9 times out of 10, not only do you have to like learn whatever the API is for the third-party library, but you also have to learn whatever weird, new, interesting, different, not invented here memory management system they've decided they're going to use for their libraries, right? And when you're working with Objective-C, of course, it's all very much standardized, and if you just follow the standards, you're good to go.
Okay, so everything we have spoken about so far is applicable for macOS 10 of any version, is required for iOS, for iPad and iPhone devices currently. And here, so people will learn that. But I understand next there is another alternative on iOS 10.
Yes, there is.
So when we come back, we'll have a look at that.
Sounds great.